Ladies and gentlemen, and welcome to 10.1 of Mrs. Quinn's geometry class. Today we're going to talk about surface area. We're going to start unfolding our three-dimensional shapes and looking at what two-dimensional shapes create the three-dimensional solid. So first of all, let's start off with this right cylinder. It's standing straight up and down, so it is a right cylinder. And if I unfold it or take it apart, hopefully you'll agree with me that I would have two bases that are circles. So I'll draw them right here. And then holding these two circles together is something that wraps all the way around. It's actually a rectangle. And so let's look at these pieces right here. Right here, if I unfolded this circle, this whole length has to wrap all the way around the circle that it's touching, right? And so how would I find out how far that is? Hopefully you'll agree with me that the distance around a circle is 2 pi r. So if that's the radius or that's the circumference of my circle, that has to be the length of this rectangle. This piece right here is how high it goes, and we'll call that the height. So if I'm looking for surface area, I would need to know my radius, and I would need to know my height. Because once I know the radius, I can find the area of my two circles. And if I know the radius and the height, I can find the area of my one rectangle. All right, let's go ahead and do it. I've got two circles and a rectangle. Down here I had 2 pi r and times height. And so if I write out my surface area, let's say we have two of these circles. And we all know the area of a circle is 2 pi r. And I have two of them. Does everyone agree that takes care of this surface area and this surface area? Good. Then I'm going to add to that the area of this rectangle, which is length times width. So that would be 2 pi r times height. Now that I've set up my surface area formula, I'll simplify it just a little bit. Let's plug in the values that we were given. I was given a radius of 5, and a height of 12. So here I have 4 times 5, which is 20 pi. Here I'll have 2 times 5, which is 10, times 12 is 120 pi. Add those together and I get 140 pi. Unless otherwise specified, we're always going to use exact area. And I'm using centimeters, so I would have centimeters squared. Good. All right, surface area of a prism. Hopefully you'll agree with me that a prism I could unfold and my lateral areas create 4 rectangles. My bases would create 2 squares. Would you agree with that? Now let's go ahead and look at our surface area formula. I've got 2 squares that are side times side, and 4 rectangles that are side times height. And I'm sorry, I've got 2 of those that are side times side. So I've got 2s squared plus side times height. Now let's come over here. We just found our formula, so I'll rewrite it for just a second. All right, and my sides here were 11 by 11, so I would get 11 squared, and 2 bases of 11 squared that would cover the top and the bottom. Now, I've got 4 of these, so I don't just want side times height. I'm sorry, I need to go back to the previous page, don't I? Oi! Let's make that 4sh. Now I'm okay. My apologies. And so I should have 4 times each area because I have 4 of these rectangles. Agreed? All right, so I've got 2 times 121 plus 44 times 36. And I end up with 121 times 2 is 242. 44 times 36 is 1584. Let's add those together and I get a total area of 1826, and my units are inches, So my answer should be in inches squared. If you want to add this formula right here to your theorem definition postulate page, I would recommend it. You've got this area for a prism and, oh, I got erased. Here we go. This surface area for a right cylinder. All right. If we're using formulas for the surface area of pyramids and cones, these are what we're going to use. This is our slant height right here. We can see our height and our radius. And I would recommend that you write down these formulas as well. So far in this video, you've got surface area for a right cylinder, surface area for a prism, and write down these areas as well. We will be using these a lot in the next few days. So, let's look at the surface area of a cone. We've got base area plus lateral area. So I'm going to come down here. I have my base. I have one circle, pi r squared. And then the lateral area ends up being 1/2 times the slant height times your circumference, or 2 pi r. So when we come over here to actually try it, we're going to call this surface area equals pi r squared plus 1/2 times the slant height times the circumference. Times the slant height times the circumference. And circumference is 2 pi r. Agreed? All right, now we're going to plug in values. My radius is 4. My slant height is 11. And again, my radius is 4. So when I simplify, I'm going to get 16 pi plus, it looks to me like 44 times 1. 1/2 times 2 will cancel, and I'll get 44 pi. And when I combine those, I'm going to get 60 pi. My units should be inches squared. Now this is a great intro for what we're going to be doing a lot of in the next 2 days. So for practice for tomorrow, I'd like you to find the surface area of this cone, and I will see you tomorrow.